Good day, grade 12 physical sciences learners. Today we're doing the third audio on electrochemical cells. Today we're doing the electrolytic cell and its applications. Have a look at the schematic diagram of the electrolytic cell. So in an electrolytic cell below, you are having aqueous copper chloride, CuCl2, which is blue in color, is placed into a beaker with 2 carbon electrodes. Each electrode is connected to the terminals of a power source. It may be a battery or a bulb in other textbooks. Anode is connected to the positive terminal of the battery, and the cathode is connected to the negative terminal of the battery. The electrical energy in the power source causes oxidation in the anode. Chloride ions are oxidized into chlorine gas, and reduction half reaction in the cathode. Copper 2 plus copper ions are reduced into copper in solid form. Copper chloride in aqueous form forming a copper in solid form plus chlorine gas. Then the reduction half reaction. Copper ions Cu2 plus 2 electrons are forming copper in solid form, since a reduction is the gain of electrons. Then in the oxidation half reaction, the 2 chloride ions are oxidized into chlorine gas plus 2 electrons, since oxidation is the transfer of electrons. Then the redox reaction, we are having a copper ion Cu2 plus 2 chloride ions forming a copper in solid form and chlorine. Then if you are just applying you are calculating the standard electrode potential for this particular cell, it will be E standard cell will be E standard reduction minus E standard oxidation. Then if you substitute, is equal to plus 0.34 volts minus plus 1.36 volts, giving you a minus 1.02 volts. You can see in this particular cell that the E standard cell is negative. A negative E standard cell value indicates a non-spontaneous reaction. A negative E standard cell value indicates a non-spontaneous reaction. In electrolytic cell, electrical energy from the power source is converted into chemical energy. Electrolysis is a chemical process in which electrical energy is converted into chemical energy, or the use of electrical energy to produce a chemical energy. Write the differences between the electrolytic cell and the galvanic cell. Do not confuse the conversion of energy. Electrolytic cell, EE, electrical energy converted into chemical energy. In the galvanic cell, chemical energy is converted into electrical energy. Then also let's consider at least the 2 applications with regard to this electrolysis process. Then the application of electrolytic cell can be used in a process of electroplating and also in electro-refining. Then once you are talking of electroplating, let me remind you about the silver spoons. Let me remind you about the copper rings and so on. Then I will say that with electroplating of an iron spoon with silver and nickel, so that you say you are having silver spoons or you are having nickel spoons. Electroplating is the process by which a metal object is coated with another metal to improve its appearance or to protect it. The object that is coated is the cathode. The cathode is connected to the negative terminal of the battery. The anode is connected to the positive terminal of the battery, transferring electrons. The electrolyte is the metal salt of the anode. At the anode, silver in solid form is oxidized into silver plus an electron. At the cathode, silver ions plus electrons, so silver ions are reduced into silver. So that's why you are saying that we are having a silver spoons. With regard to electro-refining, you can clean your copper ring by the process of electrolysis. The process is called electro-refining. Then if you consider the refining of copper, then the impure metal, the copper that is not clean, such as copper, can be purified by the process of electrolysis. The purification of a metal by means of electrolysis is called electro-refining. The impure copper is put on the anode. Electrons are transferred from the anode, and the clean one forms the cathode. The electrolyte used in this process is an aqueous solution of copper sulfate. Copper is oxidized and goes into solution together with the impurities such as zinc and iron. At the anode, a copper solid form is oxidized into copper 2 plus 2 electrons. At the cathode, the copper ions are reduced to pure copper metal, but the less easily reduced metal ions are the zinc and iron. They remain in the solution, the impure ones. At the cathode, copper ions are reduced into copper solid form. At the end, your ring has been cleaned through the process of electrolysis. Read and consult the textbook. Enough for the day.